All right, folks, so here is a recap on week 24 Tuesdays, number 6 and number 7. Okay, so this should be pretty straightforward over here. So water in, okay, water pumped in is there. Water leaving or leaking is that, okay? And if you want to find the net change in water, you subtract top pink with bottom pink, okay? And so we have this equation over here, and we got the 120 because that's the starting. Okay. So so let me rephrase what I said about the net water. Okay. So when you subtract R of t, which is this, and L of t, okay, you get the net rate. Okay, you get the net rate. All right. So remember, when you integrate a rate function, you get to an amount function. Okay, so from t equals to 0 to whatever t for until a, okay, we can use any variable. When you integrate the net rate, you get the when you integrate the rate, I should say, you get the amount. Okay, in this case, the amount of water. So we're going to do 120 plus the amount. Okay, which is which is going to be our amount at any time of a. Okay, at any t equal to a. So we got, okay, again, we're going to use the EVT, all right, extreme value theorem. Our endpoints are always going to be the first and last points of our chart, okay? And for 0, okay, you plug in 0 into A, okay? And for 10, you plug in 10 into the A right there, okay? And literally, you've watched this. You get the one. Oh, sorry. So here, let me use a different color than gray. Let's use blue. So here, okay, look at what happened. Well, this is obviously going to be 0, sorry, because the lower and upper bound are the same. So so you're just going to get 120. Okay. Now here, 0 and 10, look right here, 0 and 10. And then R of t minus L of t is that right there. Okay, which is this minus this. Okay, let me change this to pinks or to blues now. Okay, so blue minus blue. Okay, is blue minus blue, which is R of t minus L of t, 0 to 10, 0 to 10. And you get negative 49, and you got to add that back with the 120, and you get 70. So hence they got the 70. So you know how to get the 120 because it's 0, 0, upper bound and lower bound is the same. 120 plus 0 is 120. You know how to get the 70. I just showed you. Now, how do we get, what's up with this middle function? Okay. Now, remember, let's say we have a function that looks like this. Okay. And this, let's say this is our amount function. Okay. It's historically S of t, but let's just say it's amount function A of t. Okay. And so if we just think of this as S of t, this right here is our minimum, which is when at this location over here, your derivative is 0, or going back to position and velocity, this is where your velocity is equal to 0. Okay, so any minimum and maximums, okay, any local minimum maximums is going to be when your velocity function is 0. Okay, or better yet, let's just say it this way, or v of t, which is the derivative, okay, is equal to 0. So again, let's repeat that. So anytime you have a local minimum or maximum, that is when your velocity function or the derivative of your position function or amount or derivative of your derivative of your position or amount function is equal to 0. Okay? So what we're going to be doing is we're gonna look right. Let me zoom in on this real quick so you guys can see it better. Okay, let me zoom in on this so you can see it better here. So if you look here at this equation, all right, we're gonna literally subtract, okay, uh, we're gonna subtract red with red, and we get this right here, red minus red. That's our net, that's our net rate, okay? And remember, rate is at the velocity level, it's at, which is the derivative of the amount, okay? So we're gonna find where the rate function, in this case, remember the rate, there's two rates, so you're gonna subtract it. We're gonna find the rate where the rate is equal to zero, or visually speaking, where the where the x-intercept is, okay? Where the x-intercept is, all right? So again, we usually find where velocity is equal to zero, but this time we're dealing with rates, and remember, rates is conceptually the same thing as velocity, so we're finding where the rates are equal to zero, or in this case, or visually speaking, where the x-intercepts are, okay, for this rate. All right. Remember, don't integrate this. Don't integrate this, because when you integrate this, you return it back to the level of, you move it up the level back to the position or the amount level. Okay. So again, so you enter this in your calculator and use the second trace function. Okay. Use the second trace function and go to option 2, which is zeros, and put a left bound somewhere here, put a right bound somewhere here, and press enter on guess, and it'll give you that. Okay? And so this is where so you find out that this is 6.866 right here. Okay? Now this is where we know this is a minimum, because this is when the slope, remember, velocity and rates is at the slope level, because it's a derivative of the original amount or position function. This is when the slope is negative, and this is when the slope is positive. And if you look here, the slope is negative and then the slope is positive, which means this is a minimum at the position or amount level. Okay? If it was if it went in reverse, if your graph looked like this, okay, then this is when the slope is positive in the position or amount level, and then it goes to negative, and then the slope goes to negative at the position or amount level, which means it goes positive slope to negative, which means it would be a max if your graph looked like the green. Okay, so we know this must be a local minimum. Okay, but so we're gonna see where now it's asking for what is the minimum amount of water. So we're looking for the absolute minimum. Okay, we're looking for the absolute minimum, and this is the smallest. Okay, this is the smallest out of this number, 120, 63, and 70. This is the smallest. So in actuality, it doesn't really matter whether or not maybe I went a little too far in analyzing whether or not this was a minimum or maximum, whether this 6.86 was the x value of a minimum or maximum location. We just need to see that this 63 is the smallest y value out of this, therefore it is the answer. Okay. Now let's go ahead and look at number 7 real quick. Number 7 is very similar in its approach. Okay. So again, we have using the EVT, we're going to plug in our 12 and 17, which is noon and not noon, sorry. I'm missing some words here, I think. Nope. 5 p.m. Where are they getting this? People are teased. Where are they getting this 5 p.m. over here? Let me look back at the original Maybe I copied and pasted the wrong thing or forgot to copy and paste the whole thing. Let's look over here. R, boom, 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 2 rates, and this is number what again? Ah, yeah, I'm a dummy. I forgot to copy the actual question. Haha, sorry about that. Um, I hope I didn't do that in the original. Maybe that's why there was a question on it, because I forgot, maybe in the PDF I forgot to copy this A and B. But let me double check that real quick. Let me see. Actually, I have it here. Just want to make sure that I put the A and B. If I didn't put the prompt on there, that's kind of hilarious. Let me see. Make sure I put the prompt there. 24 Wednesday. Whoops, sorry, I meant Tuesday. Yeah, I totally forgot to put the prompt in there. I'm such a dummy. But this is pretty much the same problem as number 6. So let me just quickly go over this as punishment to myself for not putting the prompt in there. So no wonder people had a question on that. But it doesn't even matter because you have the paper copy. Okay. But anyways, so I'm still going to go over this. You probably saw the prompt already on the paper copy. So this is the prompt for number 7. I'm just going to put it on top. Okay, so again, at what time is the number of people from noon to 5? So noon is 12 hours after midnight. Okay, so midnight is our reference number. So that's why it's 12. Okay, and 5 p.m. is 17 hours after midnight. So it's 17. And again, by the same logic, we are going to what should I call it? Okay, so this is the amount of people joining. This is the amount of people leaving. Okay, so we combine both rates by subtracting this rate with that rate to find our net rate, which is this. Okay, so that's our net rate right there. And you integrate the rate to to bring it to bring it to the amount level. Okay, so if you integrate this, you will get the amount of people that join the ride, and you got to add the 750 because of this 750 right over here. Okay, let me do this just so it's not confusing people. Okay, let me take this, let's move that up, go like that. Okay, so let's make this just a tad bit bigger here and move that up here. Okay, so we got the 750, which is the initial amount. We integrate the net rate, which is joining minus leaving, okay, which is going to be joining minus the leaving. All right, you can see that over here also. And you integrate that to get to the amount level. And yeah, okay, so that's our general equation right there. Now, let's go ahead. Let me change this to pink, okay, just so it's not too aggressive of a color, so to speak. Okay, now we plug in 12 into, this is just like the other problem, 12 into the A, and then 12 and upper bound, lower bound is 12 and 12, so it's 0. So this whole thing becomes 0 right here. Okay, this becomes 0. 750 plus 0 is just 750. So we took care of the first line. 17, we plug in 17 over here, and we use our calculator, okay? And you can literally put this pink minus that pink into where y sub 1 is, and then you'll get 830. Okay, you just plug this in your calculator, and where you see y sub 1, put this minus that. And here, how did it get the 15.64? It's the same idea like we did earlier. We want to find where the velocity function is 0, because where the velocity function, which is the derivative of the amount function, is 0, is where there's a potential local min-max. Okay, so that's why we set the velocity function, or in this case the net rate function, which is here and here. Okay, pink minus pink, look at pink minus pink. okay, pink minus pink, and find out where it's equal to 0, which is visually the x-intercept. Okay, so we use our graphing calculator, do second trace again. Okay, second trace to find and go to 0. Okay, and then do left bound roughly here and there, and to find out your x-intercept is at 15.64. Plug in 15.64 into your graphing calculator right here in this format. And again, instead of y sub 1, put in this pink minus that pink, and you get 842. Okay, at what time is the maximum occurring? The maximum occurs at 15.64 hours after 12 a.m. because this is the highest y value right here. Okay, and that occurs, and your maximum y value is asking for the actual number of people in line is 842. Okay, thanks for tuning in, folks.